We present a new method to generate realistic terrestrial planets using diffusion models. Here we showcase some of the diverse planets generated using our method. Apart from planets with a similar climate to Earth, our control method allows artists to fully express themselves with examples such as a Mars-like planet with oceans and lush coastlines, a snow-covered planet with small oceans, a planet with a massive ocean and small tropical islands spread throughout, a version of Earth after a new ice age, or a realistic texturing of tectonic plate simulations of Earth from millions of years ago. Our high-fidelity outputs support flyovers from an altitude of a few thousand kilometers. Next, we demonstrate a typical workflow with our interface. We begin by generating initial continents using simplex noise. We adjust a low-frequency noise for the continents and a higher-frequency noise for the inland terrain. We then add some noise to the latitude-driven temperature bands to add some variation. We also increase the effect of elevation on temperature to cause the high-altitude regions to become colder. A combination of noise and a lookup table provides the initial land cover, and we preview it here. In the next phase, we focus on fine-grained control to create a desert island. We use the lasso tool to sketch a rough outline for our island and rely on simplex noise to improve the roughness and fine detail of the coastline. A similar tool is used to add a mountainous region to the center of our island. Note that the highest altitude region appears snowy in the preview. After a few seconds, the derived river network is overlaid on the elevation. We can use the filters to remove small rivers in purple and pan to see the rivers with the greatest accumulation indicated in blue, green and yellow. Now we can generate the planet. This provides a good visualization of how the tiles are generated and blended on the sphere. Upon viewing the rivers on our small island, we see that they are barely visible in the satellite image. We provide tools to artificially increase the precipitation in an area to increase the accumulation of downstream rivers. After deriving the new rivers, we select an area to regenerate and observe the resulting river with a wide delta. In this case, the delta is too large and appears unrealistic, so we lower the river classifier free guidance scale to produce a more realistic river with lush banks and a delta at the mouth of the river. Finally, we export the planet to Blender and render an animation.